In the experiment, the copper pennies with Mr. Wingard's face represents the nuclei of atoms, while the cardboard pennies with Mr. Tiggis's face represented alpha particles. Mr. Wingard can't be pushed around by Mr. Tiggis because Mr. Wingard is much cooler, which is represented by mass in this experiment.
As a control, we placed an atom nucleus in the middle of a table. This is the target. Using our finger, we shot another nucleus at the target. Notice how the projectile slows down and the target bounces away. This is because the projectile and the target have the same mass.
Next, we used an alpha particle as the projectile. When the projectile hit the target nucleus, the target barely moved and the alpha particle bounced off at an angle. If the alpha particle hit the target directly, it bounced backwards. This is because the nucleus had a much greater mass than the alpha particle.
Now we modeled Rutherford's gold foil experiment. We arranged nuclei in a pattern that demonstrated the density of gold and launched alpha particle projectiles at the pattern. Sometimes the alpha particles went through the pattern untouched, but most of the time the alpha particles hit one of the nuclei and bounced off in a nonspecific direction.
We arranged nuclei in a pattern that demonstrated the density of aluminum and launched alpha particle projectiles at the pattern. Because aluminum is less dense, the alpha particles pass through the pattern more often with fewer reflections.
Finally, we arranged nuclei in a pattern that demonstrated the density of lead and launched alpha particle projectiles at the pattern. Because lead is much more dense than aluminum or gold, no alpha particle projectiles passed through the pattern and many of the projectiles bounced straight backwards.
So you might find yourself asking, how does all this point to the nuclear atom model? Let's say, like Rutherford, you didn't know what your target was made of exactly. If you were to launch a projectile with a known mass and velocity at this target, you would learn something about the target by studying how the projectile behaved. If the projectile always bounced back, you could conclude that the target was made of many particles packed close together. If the projectile always passed through the target but came out at a slight angle, then you could conclude that the target consisted of many light particles. Finally, if the target went through most of the time but bounced straight back very rarely, it could be concluded that the target particles were very heavy but very far apart. This is exactly how Rutherford came to his conclusions.